In this class, we will see how the flat slab can be designed. But before that, we should understand the concept of flat slab. So where and all it is provided, and what are its advantages and limitations. So here, the flat slab behaves like a two-way slab which is directly supported down columns. So normally, you know that in any structural framed building, slabs will transfer the load to beams, and beams thereby transfer the loads to columns, and then columns they will transfer the load to footings and footing to the soil. This is the load transfer mechanism. So here, in the absence of beams, the slabs can be directly supported by columns. So such slabs are called as flat slabs. So in the absence of beams, but of course, when you go for the design, the structural behavior will be in the form of it is like a behavior of beam only. But I will discuss that later. The thing is, so you will be having in the plan, it looks like this. Flat slab looks like this. So suppose if we take a panel like this, so this is the plan. From the top, so you can see like this. So this is the panel of the flat slab. So you have 4 columns here. So this is one column. So this innermost is the column. So here also this is the column. I have taken circular column here. So instead of circular, it can be rectangular or square also. So these are the columns. And spacing between the columns is this. This is spacing between the columns. Spacing between columns. And you have another circle here, concentric circle, which shows the column drop, or sorry, column head. So this is the elevation. So column is this is the column. So we are going to provide one diverging portion like this. So that portion is called as the column head. That is shown here as the second circle. So these two are concentric circles. If the column is circular, so column drop also will be circular in plan. So these are the column drops. Then you have a column heads. Then you have this square portion. Of course, I have shown here square portion. This is nothing but the drop panel. So you can see here there is a drop panel here. So the depth of the flat slab is increased in this region. So this is called as drop panel. So that is a square shape here. Since we are providing circular columns, so drop panel will be square because the behavior will be similar, identical in both the directions. Yeah, this is the drop panel. So this is drop panel. This is the column, and this is the column head in plan. It looks like this. So center to center distance between columns will be like this. Spacing. Now in elevation it looks like this. So these are the components of flat slab. So this is the flat slab column. Then you have a drop or drop panel, and you have a column head. So these are the column runs like this. So these are the parts. So first part is this flat slab or the slab portion, then the column, then you have the drop, then you have the column head. So there are four important components. Of course, we have to design the reinforcements for all this by taking the loads and finding the bending moments. So you have 4 types in flat slabs. So the first one is flat slab with drop and column head. So this figure which I have given here. So in this case, we have both the drop and the column head here. So this is one type. Second type is flat slab with only column head. So you need not provide drop panel. So only directly you can provide this column head. But this all depends on the situation of the load on the structure. So only column head is provided. There is no drop panel. This is second type. Third type is flat slab with only drop. So we are not providing this column head, we are providing only drop. Okay. Next, fourth is we are not providing any drop or any column head. So in such a case, the slab behaves like a plate. So this is called as flat plate. You can see that there is no drop panel, also there is no column head. So this is designed as a flat plate using plate theory. So these are the four types. So in the question paper they may ask, of course you don't have this flat plate design in your syllabus. So any of these three they can ask. So you will be asked to provide both drop and column head, or you will be asked to provide only column head, or you will be asked to provide only drop. So depending on the problem, you have to calculate the moments and you have to design. There are some advantages of this flat slabs. So simple form work and reinforcement layout. So the design, of course, the steel what we are providing in the form of bars by providing suitable spacing. So it is very simple thing. So then, and also form work also will be very simple. Then for shorter story heights, so if the story height is less, so then you can go for flat slab. So if this story height, if it is less, then you can go for flat slab. This is called as story height. Then fast construction, flat ceiling and economic. So the construction is fast compared to your beam slab structure. The construction is fast and ceiling is flat. So this is the ceiling. So there is no need to go for any curved thing or any, what we can say, like this kind is not required. So it's a flat ceiling. Then it is economic also. So studies have shown that flat slab design is economic. Next, fourth one is more flexible in the layout of columns, partitions, small openings. So flexible means you can incorporate any changes required easily. That is the meaning. You can change the layout of columns or partitions if there is any, or if you want to provide some openings or ducts. So that is also very easy. Suppose if you provide a beam, then providing ducts, you need a certain care because reinforcement may be damaged and all those things. So here there is a flexibility for these things. Next, the slab thickness is sufficient. So normally slab thickness will be 125 or 130 or 150, something like that. This is sufficient to take care of the fire resistance. So fire resistance can be achieved by providing the sufficient slab thickness. So these are the advantages of flat slabs. Of course, only limitations are very less. So it is subjected to two-way shear. So you should be careful in shear calculation because flat slab may fail due to shear. So two-way shear is also called as punching shear. This you have studied in a design of footings in RCC 1. So we are going to check the shear for two-way or punching. That is one thing. If it is failing, then we have to provide this column head and drop panel, all those things. So to check for shear, column head or drop has to be provided. That means if it fails in shear, if you are not providing those things or any one of those things, then you may have to provide both the things. So that is the only check we have to make. It is very important in flat slabs. Now coming to how to fix the thickness of slab, it is similar to two-way slab. So we are going to take the ratio, L by D ratio in IS 456. It is there. So when I pick up the design problem, I will tell you. So using that L by D ratio, we have to fix the thickness of slab based on the deflection criteria. And normally the minimum thickness is assumed as 125. So thickness of slab should not be less than 125. Then coming to the drop panel, if you take this DS as the overall or thickness or depth of the slab, then if you are providing drop here, this is the drop portion. If you are providing this drop portion, so the thickness of this total, this overall depth should be greater than or equal to 1.25 times ds. That means this drop thickness should be greater than or equal to 0.25 ds. So this is ds, this is 0.25 ds, total is 1.25 ds, and also the span of this drop panel. So this is the span. So if I take the center line of the column, this is the column. If I take the center line of the column, so from the center line, this drop length, this drop panel length should be greater than or equal to L by 6 on either direction. That means it is totally, it is greater than or equal to L by 3, where L is the longer span. Please note that L is the longer span here. Suppose if it is rectangular, you have to go for the longer span value. So this is how we can fix the thickness and the drop panel dimensions or proportioning for a flat slab. So there are 4 types. So which panel, with only panel, with only drop, then with both panel and drop, then without the panel and drop. So 4 types are there. Advantages I have told, limitation I have told, how to fix the thickness and the proportioning drop panel I have explained. Okay.